Oh man, everybody, do we have some exciting stuff here today? I just received the biggest and heaviest package I think I've ever had delivered here. And also, hopefully, most exciting. So, okay, it's here. Got a little gash in it, but that's fine. I'm sure it'll be fine inside, I hope. Well, let's just start tearing it open. Ooh, there's stuff inside. Okay, got the instructions and a parts list. Man, where do we begin? We've got a Z-axis. Wow. This is a 2080, I believe, on the back. Very nice guides on here, actually. This is pretty cool. We've got one, I believe, dust plate. Oh, I think, no, these are the dust shields. Very nice controller. I believe is the X-axis. A random bracket. The brush. That comes out last. We've got the USB cable. And it comes with, we've got some, I believe some raspy bits. Good for wood. Here, a sample piece of MDF. The Z limit probe. Tools for assembly, and then tools for the collet. Wow, very nice, nicely labeled box of hardware. Got another set of bits. I believe these are V carving bits. Some very nice looking hold downs. We've got 2 USB drives and an SD card. Here is the 300-watt spindle. got the power cord. Wow, this is a solid aluminum spindle clamp. I've never seen one this beefy. A couple more brackets in the corner. And I believe the whole base plate comes out now. I guess with the foam. All right, we're struggling here. Let's get this out of the way here. Hold on. Okay, that is pretty heavy. Wow. Check out these wire tracks. They're massive. Main wire loom for connecting to the back of the controller. Very well labeled and hopefully pretty foolproof. Alright, I still think that the whole base has to be pulled straight up. Well, that's one way to get it out. So this is the back side of the waste board. It's got these nice screwed in threaded inserts already done, and then spots for bolting it to the frame. All right, step one of assembly is the base to the waste board. So for that, we need the base, and then we need the waste board. There's already pre-drilled and tapped holes in the extrusion here. You just have to line them up. And we need 6 of the M5x20 bolts. Alright, so what I did there, you want to first get them just started, and then once they're all started in there, then you want to tighten them down. Alright, after the wasteboard is bolted down, we're going to attach the dust baffles. They help keep the debris that's flying out off the wheels and off the carriages. And there's also pre-drilled and tapped holes at every corner that accept these. Step 3 of the assembly is attaching the gantry. This is the gantry right here. And I'm very careful, and I look at every axis on here as I'm putting it together. And one of the y-axes, that one over there, the roller wheels were a little too tight. And on the gantry here, they are, I think, too tight. Very tight, actually. So if you look, these are the screws that tension the wheels down. But if you look, you can actually see a gap here. These bolts here actually I don't think are tying down. You can see that the lock washers aren't even collapsed. And you can see a gap down the line here. These blocks, they should be bolted down. So it's not a big deal. These are torqued down too much, and these aren't torqued down almost at all. So we're going to loosen these, make sure these are on the right spot, tighten them down, and make sure that this thing rolls smoothly, because as of right now it barely moves down on its own. Alright, so what we're going to try and do here is to make sure we close up this gap here and this gap down here. So we're going to start by loosening these bolts up here. Now it's loose. What I'm going to do is I'm just going to lightly apply tension on here until it's not loose no more. Now it's not loose. Now what I'm going to do, I'm going to torque this side down. So I did not even loosen these bolts. They were loose like that right out of the box. So what I think I'm going to do is I'm going to re-loosen these. And that makes the carriage wobbly again. And I'm going to go back again and snug it up again until it's just a little snug and not wobbly anymore. Still wobbling. Alright, now it's firm. Now that it's firm, I'm going to snug these bolts here. perfect. Alright, now that we've tensioned the roller wheels on the gantry, the x-axis, begin assembling it. The way that you want the tension set up is you want it to just slowly roll down on its own and very smoothly all the way down. And to stick it in here, you gotta kind of spread the plates a little bit. Got a little bit of preload. And they go right on. Alright, the x-axis gantry is attached to the Y carriages with two M5 by 12 bolts on either side with a lock washer and a flat washer. The next step of the assembly is putting the Z-axis onto the carriage. And I always stress to look over every nut and bolt, and I'm glad I did. So one thing to keep in mind and to understand is that the lead screw here, as it's driving the carriage forward or back, that force, it has to be held back by these thrust bearings. And usually they'll face each other on one bracket, and there'll be a nut with a set screw to set the preload on the thrust bearings. But here there is no nut to do that, so it's actually, I notice it's this plate here. This plate is what holds it, and on mine it's loose, so you can actually wiggle it, and then if you see, now there's a gap right here in that thrust bearing. So this could actually move back and forth, just the lead screw. So it's not a big deal. I'm going to stand this up, and I'm going to make sure that this is pushed down as tightly as it can go. And then back here there's 4 holes that with a narrow Phillips screwdriver you can get in there and tighten them down. So, and all 4 of these screws on mine came loose, and that would have given me a lot of backlash on the Z-axis and probably a lot of vibration. But hopefully now, and after I go over all the nuts and bolts again, it should be a very reliable machine, or at least rattle less, vibrate less. So now we're good. This plate is on here tight. Now we're gonna go forward with mounting the Z-axis to the carriage. That's done with these M5 by 25 flathead cap screws, and they go right in through where the extrusion has these cutaways. You're just gonna want to make sure you move this out of the way so you can get them all through. So if you'll notice, I've got it just loosely tying down, and there is some room. It can be tightened down this way or this way, and later on, once I have it all assembled and put together, I will run the spindle up and down and across the whole bed, and we will do our best to make sure that all the axes are perpendicular to each other and nice and true. So for now, I'll just torque it down in its natural resting position. So I can't quite get this end in there to really give it a good amount of torque, so what I like to do, I like to stick or open end wrench or box end wrench, I'm sorry, onto the end of here to get extra torque on these, because I definitely want to make sure these are tight. Next step is the spindle mount, which I really like. This is solid aluminum, and I can barely even flex it with my hand here. And very nice thing about this one, my favorite feature, are these notches here. Look at these notches. Very important to have those, because that's how you can fit a laser module in here. And what good would this machine be if you couldn't also just mount the laser module right there? So we'll start off with the spindle first. So we're gonna put this on. Alright, the spindle bracket goes on traditionally with the cutout to the right, and it uses two M5 by 55 bolts torqued down on the left. The right ones also hold down the spindle, so we're just gonna put the left two in for now. Actually, we'll just stick the other two in right away. So as you can even see, even the spindle bracket has give one way or the other, so even that will need to be squared off. But for now, we'll just let it sit in its resting state, and then just carefully torque these two down so that they don't go anywhere. Put on our 300-watt spindle. Has a fan built in up top that's run off the same axle. Very easily accessible and replaceable brushes, and an ER11 collet with a 1/8 inch collet in there right now. That was a very snug fit. But I think that's good. It's flush on the bottom here. So we'll torque down these bolts. I think it's pretty good. Okay, next we will be installing the Y-axis drag chain brackets. We'll start off with this one here. The other one is the one with these slots, and it goes into these T-channel nuts right in there. Now we will do the X-axis wire track brackets. This one goes right up here. And the next one is this big one here. And that goes on these little end plates right here. This next step is probably going to be the most exciting step of all. Well, other than probably doing your first cut. But it's the drag chain installation. Again, I'm so excited about this. I've never had such massive wire tracks before. So we'll try and start from the spindle end and work our way down to the Y-axis and then do the Y-axis. Now we're gonna want to make sure that this is not twisted the wrong way. We want to make sure that it's sitting in its natural resting state. Once the drag chains are all bolted down, now we begin the process of connecting all the plugs. Everything is very well labeled, and we'll start off with the Z motor, which is right up here. Plug that in. Here we have the X motor, which is right here. We have the X limit switches, and they plug in right here. Right over on the left side, we've got the Y1 motor connector, and the Y1 motor is here. And then we have the Y limit, and that plugs in from this cord right back here. Back over here we have the spindle wiring, and that we've got negative goes to negative, positive goes to positive, and then we've got our Z limit switches. So you want to make sure that it doesn't rub on the fan here. So we might have to zip tie that somewhere off to the side. Alright, one of the last things to do on the machine side is to run the Y2 stepper motor cable up to the Y2 motor, and that goes underneath the X-axis drag chain bracket. And there's these clips, 4 of them, that hold this up and out of the way. And we're going to do that right now. And then we plug the stepper motor in. So I've taken upon myself to open up the control box here just to see what's inside and how it's done. And I'm quite happy with what I've seen in here. So starting off here, we've got the main AC coming in, and goes into this multiple voltage out power supply here. The 48 volts I believe is for the spindle, and from the front this potentiometer for the spindle speed connects right up to the control board here, so that's how that voltage is varied. The main power switch here, and this controller is very interesting. It's big, it's huge. One thing I've noticed is that it actually has 4 stepper drivers, so it's technically a 4-axis machine, and it's got individual Y stepper outputs, and that's might open up the possibility in the future to have individual Y-axis homing to make sure your gantry is always square. These flip switches, I'm gonna assume that half of them are for the micro steps and the other half might set the stepper motor current. I wish I could take the heatsink off. It's a little difficult here. I was told that the stepper driver chips are the TB6600s or something. I will have to confirm what that is. Right here, just like on the old controllers, they have a coolant output. I'm gonna hook up a wire to here so I can turn on and off a vacuum for this machine. That way I don't have to flip it myself. And then there's feed, resets, and start connections here. I can focus on them. Feed, hold, reset, and start. The rest of these connections here I believe, for the limit switches. Z probe, Z limit, Y limit, X limit. And those are all hooked up there, and they are either hot wax or hot glue. Make sure they don't shake off or vibrate loose off the board, because then you could have a problem then. And then there is a cutout in the side panel here, and I could see a flip switch, which I wasn't sure what it was for, but now that I see it, that is for the laser output. And I'm very much looking forward to hooking up a laser module to this machine. So in order to use it, you have to kind of stick your a little screwdriver in here and flip it over to the laser output mode, or else this way it just stays here. This output here would normally be for a spindle, but this is only 24 volts, and I believe it's handled by this transistor, and that's only adequate, I believe, for the 60-watt spindle. Here there is a relay which flips over this power here that comes off the power supply, and it connects it to your output right here for your spindle. So it's a relay connection for the spindle, and then you manually adjust its voltage right here. Right over here here's the USB port, and right next to it is the offline controller port. USB port goes over, and we've got it on the back here. And the offline controller is very nice. They've intercepted it here. It goes through that flip switch there and then to the controller. That way you don't have to do any unplugging. You just flip the switch and you can go between using your computer through USB to control it, or using the touchscreen offline controller here. You don't have to be flipping cables back and forth. I'm very curious what this connection here is for. I wonder if that's for a Wi-Fi module. It'd be very cool to be able to stream some code to it wirelessly. From the offline controller, there is a plug to a SD card module so that you can load your code in right from the front with an SD card. The wiring to the back of the controller is very straightforward, and it uses these very nice screw-on plugs, and they're all very well labeled. So let's start with some of the limit switches. Here is the Y limit. Here we have the X limit. And the Z limit. Next we'll look for the probe, which actually that's come separate, so we won't worry about that yet. We'll move on to, let's do the Z motor. Then we'll do Y2. Here's Y1. And we've got the X motor and the spindle. Alright, and that concludes the rear wiring. So I'm just going to quickly show how I'm going to open up this file in Candle, which is the software I use for controlling my Gerbil CNCs. And I'm going to open up our file here, and this is it for the little Millie hut. And you can zoom in and you can see all the individual passes it'll take. And right now my machine is powered off. Let me turn it on. Okay, we're gonna flip on our controller, and we're going to connect our USB cable, and it has detected the machine. Right now it's in the alarm state, always by default, so you have to click unlock. And now that the machine is unlocked, What we're gonna do is, first thing we're gonna have to do is zero out the X and Y axes, and I will go ahead and do that next. So I have my very first file loaded up, and I'm about to stick the very first bit in it ever. And I'm gonna take these raspy end mill bits that they included. This one right here is about 1/8 of an inch, and that's what I set the code to be. And we're gonna take, I usually just take the collet completely off, and we're gonna stick it right in here. I usually go just about flush in the back. Take the tools, one goes on the adapter here and the other one goes on the nut. I'm going to tighten that up nice and snug. Now we're going to need to zero out the Z-axis, and I like to do that manually by jogging it down and using a piece of paper. Go 1 millimeter at a time now. Alright, we're getting close. Now I'm going to change it to 0.1 millimeter steps, 0.1. Now I'm going to take a piece of paper, I'm going to stick it under here, and I'm going to keep going down until it's caught. Now that it's caught, I'm going to zero out the Z-axis. That brought it to 0. And now I'm going to bring the head back up. And I've already done the X and Y axis. So I'm going to go ahead and hope for the best. I'm going to send it and run it, and we'll see how it goes. So there's a very big and important upgrade that I need to make almost immediately with my 4040XE. This is day 2 of me owning it, and we're gonna be installing a laser module. The spindle already has the notches in it for it, but unfortunately it did not come with the wires in the harness for a laser already. So that's what I'm going to be doing right now. From my 15-watt module, it came with this cable. Obviously this is not long enough, so I'm going to make my own cable, because these ends here are, I believe, I'm hoping they're the same as these here. And the cable that I'm going to use is this one right here. A little bit thicker gauge, but very flexible, and hopefully won't break after hundreds of thousands of these. And we've got a crimping tool for those connectors, but I'm gonna crimp them and then I'm gonna solder them, because I just want a much better connection than just a crimp. Alright, I finished making my laser cable. I have them soldered and hot glued for strain relief. And one end of that plugs in right into this connector right there. On the left side of the machine, there is a hidden flip switch right in there. That's the switch that changes it between laser output and spindle output. And switching it towards the rear flips it towards the laser mode. So that's what I'm going to do right now. Just like that. So I want to replace the 300-watt spindle with my laser module. So I'm going to begin that by undoing the wires. And we're going to just put those out of the way. And I'm going to loosen the spindle holder. Spindle comes right out. I'm going to stick this 5,000 milliwatt module in here for now. Before I run it through all the wire tracks, I'm just going to test it out by just plugging it in. And we'll see if we can do this preliminary job just like that. Alright, so I've opened up Laser Gerbil, and I've got my laser module mounted and my Z-axis as low as it will go. Turn on my laser beam, and look, there it is. It works. I just have to focus it. That is so cool. Laser module on the 4040XE. We're about to engrave the front of this bunny hut. Let's hope that it comes out great. What I've done here is, in Laser Gerbil, I've loaded my file to scale, and I manually jogged my machine over about 300 millimeters up, but I jogged it to get it right on the point where the cutout is. And then I'm trying to match the machine to make sure that it is in the right spot, and I'm off by a few millimeters. So I'm gonna rehome or bring the machine back to its origin. In fact, let's first check just how far off we are. We'll move it down 2 millimeters, and I think that's perfect. So I'm gonna click this button, which is return to origin, beam off. And we're going to move it down by 2 millimeters. And then we're going to set the origin. So now it should be good, and we are in focus. The way I check is I will jog it to where the beam can be seen. And I'll turn the beam on. And that is pretty well focused, for me at least. And we will send it. It says about 21 minutes. We'll see how it comes out. Alright, and it is done. And I think it came out exactly as it was told to come out. Beautiful orchid flowers. Well, it came a little bit off screen, but that's fine. This piece was a little bit shorter. Look, the bunny is centered, and so is the doorway. Yeah, I just extended the file beyond what the actual physical wood was here. But these are my drill mark holes, so I know where to drill it. And this is for our cute little bunny Millie. We're gonna update her hut. Let's see how that comes out. I'm in the process here of building my own little expanded, upgraded laser machine, and I have a need to space this rail over a little bit by about 1/4 inch. So I'm going to attempt to make an acrylic spacer block on the 4040 XE. We'll see how that goes. So I'm just going to quickly try and show you guys how I personally went about creating this file. I'm familiar with Photoshop, so I used Photoshop, and I opened up an image that is exactly, well, almost exactly 20 by 40 millimeters. And I made a black background. I put 2 bolt holes and then the clearance hole for my cable through the middle here. And really I just kind of used this ruler right up top here just to confirm these sizes. Hopefully eventually I'll get better at generating these files. 1, 2, 3, 4, 5 millimeters across. So I just simply saved this as a JPEG, and then I went and I used this online converter and I upload the JPEG, and I do this because I'm using easel, and easel only will take SVG files, or at least it won't take a JPEG file. This SVG converter has a couple different formats. I'm gonna pick the ready number 1, and I'm gonna download the SVG. And once the SVG is downloaded, we're gonna go over to easel, and easel for me is by far the easiest to use. It's I think great for getting started. Our piece is going to be made out of cast acrylic, and it is, let's see, it's about 5 millimeters, 5.5 millimeters thick. The length in Y is about 76, and the width, we'll keep it at that, it's about that wide. So there you go, that's our material. And we're gonna go over, first thing we kind of want to make sure in easel is that we got the proper machine set up. What I'm doing right now, I just have other Gerbil set up here, that way it creates the proper G code, and I'm just setting it up as a 3018. What that does, that sets what your cut and feed rates will be, so automatically it tells you what the ideal feed rate, plunge rate, and depth per pass should be for that type of machine. If you click manual, you can change these yourself, but I'm going to stick to automatic for now, and we're going to stick with the 1/8 inch end mill bit, which is already selected, and we're going to try and import it. And this is just what we created here. And so if you see, it doesn't actually import it to the same size, so we're gonna have to adjust it ourselves here. And this is nowhere near precise, but it's definitely gonna be precise enough for my needs. Alright, we'll leave it like that. It's 20 by 40. And if you select it, you can set how deep of a cut you want it to be. I'm going to cut all the way through, so it's going to be 5.5 millimeters. Let's actually move this over just a little bit, and I don't want to clear out the pocket, I want to cut this piece out. So here we're going to pick cut outside shape path. So now it's going to cut outside of it and then inside of these holes, and that's exactly what we wanted. And I've brought my piece down to the edge here so that it doesn't have to do really any cutting here, just skim along it. And here you set how you want your tabs set up, and let's see if we can get that figured out here. I just want to have 2 tabs. I'm not sure why I can't scroll over here now, but you can adjust where you want these tabs to be. I'll have one here and one there. Height, we'll make it maybe just 1 millimeter, and length, we'll make it, let's do just 3.3. And I'm not quite sure why they're not showing up in this illustration, but hopefully the machine puts the tabs in. So if you click simulate, it'll tell you the time, about 3 minutes, and it shows you the tool paths and how it's gonna go about it to clear out or cut this piece out. And hopefully it comes out well. So now that it's designed and set up and we know we want it to be this way, here's how you generate the code for the machine that we're going to use. We're going to click machine, and you click advanced, and under advanced we're going to want automatic spindle control, 10,000 RPM, and then we're going to click generate G code, and then we click export G code, and it's going to save it as an untitled NC file. And that's the file that we're gonna feed into the machine. I'm gonna rename it, and I'm gonna attempt to try using the offline controller instead of using Candle for this project, and we'll see how well that offline controller handles it. The offline controller I like quite a bit. It's very well put together. It's got very powerful power supply in there, what looks like a pretty good Gerbil control board, and the interface is pretty nice. It has a nice FoxAlien splash screen. It's definitely one of the nicest Gerbil offline controllers I've seen. When you first click on control, the machine's going to be in an alarm state, and for that you have to unlock it. Once it's unlocked, then you can go into move, and here you have to set your step value, and that's how you can control it. All the axes, and you can turn the spindle on and off. The speed is controlled right here. So it's no longer software controlled for the spindle speed. You still have to enable it, so it still has to send the M3 signal, but the speed is controlled right here. And I'll show you a demonstration how the machine does its homing cycle. Once you have zeroed out the X, Y, and Z axes and you're ready to begin your file, and you're gonna have our SD card inserted right here. I'm gonna click Files, and right here Gantry Spacer is our file, and we're gonna send it. Right, so that first attempt was failure, but that was my fault. I had these clamps set up wrong, and this was not in there tight at all. So it moved around on me, and I'm hopeful that this next one will be better. Got my file right here, Gantry Spacer, and we are gonna send it. think that came out great. So I made it. It's got two little tabs in it. Feels a little warm. Cutter feels cool. So I'm going to take this out and we'll see how it came out. This is me right after pulling it out. And wow, it's just hanging on by the paper here. That is funny. Let's see these edges. Wow. That is pretty nice. They feel smooth to me. I mean, you can almost see through them. I mean, they're pretty clear. You can see these cutouts. And in here it looks clean. Now, I'm gonna scrape this paper off and we'll see how it looks. And this was done with the 1/8 inch or 3.125 or something millimeter end mill. The biggest one they got with the rasps on it. The rasps work very well. They work well on wood, and they, I think, worked very well on this acrylic here. They just leave these horizontal grooves, but to me that's not a big deal. They might even help for gluing up, sucking in that solvent. So we'll see. So the tape just came right off, and I am so happy with this result. There's just one chip on here, and that's just the nature of this acrylic. It's very brittle. That might have been when it first plunged down. Maybe I should slow down the plunge rate maybe. But look at the nice sharp corner there, and very straight. Next thing, I will see how accurate it is. I wanted it to be for the end of a 2040 extrusion. And actually, wow, I can already tell right now it's good. It is good. Okay, and here is the plate installed, the little spacer. And I am so happy with it. Not only does it fit perfect, but it even looks pretty cool. And it wasn't very hard to do. I made the file up in Photoshop. I'm just so stoked about this now. I mean, I used to just have to eyeball stuff, measure it, drill it, and I feel like now I can produce some actual legit parts here on this machine. Next step for me is going to be to get better acquainted with more precise CAD and CAM software. Alright, the machine also comes with a Z probe, and I'll quickly demonstrate how this thing works. It works pretty well. You just clip it to your bit, you put this piece right underneath, and then in Candle you click the Z probe button, and it slowly brings the bit down until it touches, and then it comes right back up, and then that zeroes out your Z-axis perfectly every time. You can confirm that by measuring the thickness here and entering that in the software. By default 15 millimeters is what these are set to. If you need it to be any more or less accurate, or if you change it, you can update that in the software. So overall, I am very pleased with this machine. I absolutely love it. It's great. My very first project that I executed on it came out flawlessly, and that is this front panel to a hut we're about to put together. And first thing I did was I routed it all out, cut out the window, cut out the doorway, and all I had to do was just lightly sand the corners from all the fuzz. But then I mounted the laser module, and the laser module did its job very well. Everything came out perfect, very nice crisp lines, and I used laser Gerbil for it, and it does not do the best job in terms of path optimization. So it was taking a long time. It did a little bit here, then it went over here, did a little bit there. I've been using Lightburn for my laserings lately, and that thing has better path optimizations. But as a CNC router, this thing works absolutely great. The second thing I did was I made that spacer plate for a 2040 aluminum extrusion, and it performed very well. I mean, it plowed through that acrylic and it didn't vibrate, didn't jitter, and it left a great finish. So I'm greatly looking forward to creating a lot more bracketry out of acrylic. I haven't tried aluminum yet. That's on my to-do list. So I will definitely do a follow-up video after I've gotten a chance to familiarize myself more with this machine and the CNC machining process. I need to get myself the proper aluminum bits, and I gotta learn about the different alloys of aluminum, which ones are machinable, and see what I can do. Some of the only downsides that I've seen with this machine is that the laser function doesn't come pre-wired with the cables. I kind of wish they did that. Not a big deal for me. I made my own cable. The flip switch for the laser mode is also, it's unlabeled and it's a little hard to get at. I wish that was maybe a little bit easier to get to, but maybe it's done that way so you don't accidentally knock it during a operation or a job. The packaging was done fairly well. I could have been done a little bit, or made a little bit more secure. And it was a little bit difficult to pull everything out, but I mean, I was able to manage, and I don't think I damaged anything on the unboxing. But there's definitely a lot of pros to this machine. I really admire the belt drive system on here. It's got a great system for engaging the maximal amount of teeth on the sprockets for the stepper motors. It's got tensioners at the ends of the belt so you can adjust proper tension. The roller wheels themselves, they have bolts that adjust their tension. There's definitely improvement to be made in the roller wheel tensioning system, but the way it is works very well. You just have to be a little bit more patient with it. I was able to get every axis honed in, I think, perfectly well. Only two of them needed some tweaking. The third one was perfect right out of the box. Originally, when I was looking forward to this machine, I thought all the plates on it were going to be aluminum, but they're actually all steel. They're like powder coated black steel, drilled and tapped. That makes it for a much more stronger and more forgiving of a machine. I really like that they're using NEMA 23 stepper motors. I mean, I can hear and feel the power that they have. I love that they have knobs on the back for making it much easier to move the machine around by just twisting the knobs instead of trying to stick your fingers in on the lead screw. I really like that it comes with two different bit sets. It comes with the raspy end mill bits, and it comes with the V-carving bits. Those are a nice big bonus. And I was able to carve the wood and the acrylic very well with the raspy bits here. So I'm still gonna have to try out the full limits of these. But these I don't think are good for aluminum. We'll have to get some specialty bits for that. So this machine, I got big motivation for me. I'm trying to build a few CNC machines of my own, and I have a need to be able to machine my own brackets and plates out of either acrylic or ideally aluminum. And I'm very confident this machine is up to the task. FoxAlien has shown a few videos of them milling aluminum with this machine, and it comes out, in my opinion, very well. So I'm very much looking forward to that. There's also going to be a 500 watt spindle upgrade for this machine, as well as a special spindle that'll take a DeWalt router. And I've seen people get tremendous success using those for milling aluminum. So there's much more to look forward to. If you're looking for a machine that can perform tasks that are not just purely educational or proof of concept, but this machine I feel you can maybe start up a small business with if you want to make some small batches of parts. I definitely think this can serve, well, it's definitely, I feel, gonna serve a ideal spot here in my shop, especially for, I mean, it's not a big operation I got going on here, but the ability to quickly design and be able to have a part within, I mean, a matter of minutes here, that's a tremendously big bonus. So hopefully, if any of you guys got anything out of this video, please let me know. Like the video, subscribe to my channel. I'm hoping to upload many more videos about the whole process here and about what I can do on this machine. Let me know in the comments any ideas or suggestions you have, or any videos you'd like me to do. I can definitely go further in depth into whatever you guys may want, but usually I gotta learn it first myself before I can spread it to y'all. Thank you again for your time, and good luck.